We have the next session of the evening, so we've got a little fireside chat lined up. So the topic, no surprise, is going to be around autonomy, but not just autonomous vehicles. We're going to talk about all things autonomous, because autonomous vehicles are, of course, a key part, and it's the sexy part, I suspect. But we're heading towards an autonomous world, and there's a lot of challenges we have to solve to get there. Hopefully, the next 30 minutes or so, we'll get enlightened. We'll solve all the problems, and we can leave here happy. Okay, so I'm joined by some guests here. So I'm going to ask each one of you to just do a 30-second intro. So Will, you first.
I'm Will Bryan. I'm from Auburn University. I'm the team lead of the Auburn team in the Indy Autonomous Challenge. And so I'm finishing up my PhD and moving on to the next stage. I'm going to be starting a company in the autonomous vehicle world.
Cool.
Great. Sean Hendricks. I'm the CTO of 912 Institute. We're a nonprofit innovation institute working around advanced communications, digital transformation, and really, trying to help facilitate this whole innovation process that we're working on, but really intersects between industry, academia, and government. So we're really trying to convene everybody and help spur that process along.
Welcome.
I'm Damien Fawzard, CEO of CoreVision. A little bit of my background is it's an entire career in technology, both in kind of the high reliability space, so cryptographic. I'm a cryptographer by training. Spent 15 years keeping secrets for a lot of organizations, many of the American organizations with three letters. Acronyms. Moved into the avionics space, again, solving logic problems. Logistics was the starting point. And in the last probably 6 years, it really has been about innovating in that space and innovating in and around safety, compute, because we could see the world changing. So I'm in it not just as a CEO, but as a really enthusiastic technology lover and problem solver. And I actually envy Will a little bit because he's at the start of the career, which is a real fun place to be. And I'm on the other end of that particular path. But anyway.
Okay. So, question number one. So we've all been working on this autonomous thing for a long time in the technology sector. Surely we must have solved all the problems by now, and there's, from a technology point of view, and the only real barrier to mass deployment is probably more around the infrastructure and the ethics of AI and autonomy. What do you think?
So I think, we have been working on this technology, but I would say we've been working on the foundations of the technology for true autonomy for a while. Damon spoke earlier, and in a lot of ways, he kind of took us on a journey of some of these systems, the early brake-by-wire systems and things like that. Those technologies had to be developed, the sensors, the control systems, had to be developed with the reliability and the cost to deploy in mass markets in order for us to build upon that to get to autonomy. And I think, I'll maybe let Will comment here in a minute, but, true autonomy, leveraging that foundation, I think is still challenging, especially when we look at the things we really want to do, right? Which is driving at high speeds. We want to see platforms working in complex environments like manufacturing plants, where there's people, equipment moving around. So I think there's still some work to go yet, but it's building on the platform that's been developing for the last couple of decades.
Well, yeah. I haven't been working on it that long of a time, but, the issues with legalities and ethics and insurance are definitely hurdles that need to be overcome, but obviously there's so much more on the technology that needs to be developed, but, people give those projections of, it'll be here in 3 years, it'll be here in 4 years, and it always gets pushed back, but, what we're doing and what's holding it back, he said we've laid the foundation. It's those edge cases. That's what the Indy Autonomous Challenge is trying to do with high-speed racing, and what Formula One has done for a long time as well. solving those edge cases. And so as we get more and more edge cases solved, as we get more data, data has been a huge bottleneck, but now we're getting tons of data, like from Kent's Tesla, they're reading it all in every single day. They know everything he does. And so, it's not the everyday driving. It's when a moose runs out in the road or a tire falls off the truck in front of you. And so I think as we're getting that data, it's really going to allow, the AI to adapt and allow the technology. So I don't think it's that far off. I think it's pretty close. I think we're starting to see it come through, and I think we're seeing level 4 autonomy systems being run in the public in a lot of cities. So I think, we're kind of on that cusp of it really spreading.
So I think we have to think about autonomy in a number of different ways to really answer that question. There are two things you can do to control autonomy. One is you can control the environment. And you see this with the IndyCar. The rules about racing early on are different from where you hope they will end up. You hope you're side-by-side, wheel-to-wheel racing with lots of cars in a confined space. That is a much, much bigger problem than one car going around the track by itself. So the kind of the bounding how autonomy works is one set of considerations. The technical consideration of can we build autonomous AI systems that are unbounded, which is the other end of the spectrum, we're a long way from that, but we are working towards it. So what I suspect is actually going to happen is a hybrid. And we see this in the real things that are being deployed. You define an operational case that people can live with for whatever the autonomous system is, and you regulate and you operate within that. Then the next thing is that space gets bigger because you prove yourself in that technology. And eventually you end up with full autonomy, where we're building systems that are human capable in their capability. I think one of the things that's interesting for automotive is that in the public mindset, we go from no autonomy to that end point in one foul swoop. So if you put your autopilot in your Tesla on, the mindset of people is often that this is a piece of technology over here, whereas everybody who's a technologist knows, no, actually it's a much more bounded piece of technology here. I think that is our danger and our challenge. It's as we evolve technology, bringing the public with us so that they understand what it actually means. And by public, you get regulators and all of those other people.
And there's a lot of value, right? In even some of those incremental steps. So I think we can take a process or a hybrid approach as we continue down the path.
I absolutely agree. I love the idea of the elevator as being the role model for autonomy. If you think of a system that we all use every day that is autonomous, it's the elevator. But that is a technology that had to evolve to be safe. If you notice in elevators, they all have safety certificates. Well, they don't have safety certificates unless people got hurt by them, because they, if there were never problems, they would never go through that regulatory process. There's a great hotel, whose name I forget, in Amsterdam that still has a lift in it that has no caging on it, and you literally step on a step and go up through a hole into the next floor and step off, which is how that technology used to be. So I think we're not at the stepping off phase in terms of the elevator. We're probably at that, boy driving it stage in terms of the elevator, and not at the fully autonomous. But we're on that spectrum, and it's inevitable that we get there.
So lots of interesting points, and I'm going to come back to each of them as we go through the rest of the conversation. But you mentioned safety. So one of the things I've noticed is I've had many conversations with, again, automotive guys primarily, but other sectors as well, is as we're going through this whole AI training and investing huge amounts of money in training these models and thinking about all of the different corner cases that can happen, there's not so much emphasis being put on the safety side of things. And I've actually heard people say, yeah, we're going to tag safety on at the end. Like you just go buy it in a box from Best Buy and just plug it in and you're good. Do you think we're spending enough time focusing and investing on the safe deployment of autonomy?
Yeah, it's a tough question because there's a balance, right? So coming out of the automotive industry, you have to have that safety to get to mass market, right? There's liability involved, the insurability. Without it, you can't have a viable business. At the same time, we're in a high innovation period, so we have to move quickly. And I don't want to imply that means cutting corners, but there are core functional challenges that need to be solved, algorithms, integrating systems of systems. So I guess in a broad answer, I'd say that there probably is a little bit more safety architecture that maybe needs to be comprehended. But at the same time, I don't mean to speak for Will, but having a chance to talk to some of the teams, what I do see is a modularization, starting to functionally partition these systems, which are design principles that make them amenable to safety processes like functional safety in automotive and such. So I think the innovators are trying really hard to find that balance.
So I'm assuming you don't need a safety certificate for a race car.
Yeah, not autonomous safe car. That's kind of, I guess, one of the benefits of autonomous racing is, from a safety standpoint, you're just worried about keeping the car in one piece. You don't have to worry as much about, the human life. But at the same time, it's really been eye-opening for me, at least, all the different types of safety you need. I mean, you have to have all the checks on all those subsystems, like you said. You have to have, checks on things crashing. You have to have checks on the dynamics of the vehicle. If you're getting too much side slip, if you're going off your path, whatever, you need to be able to bring the vehicle to a safe stop. And so even I think partially by not having a human in there and being able to push the limits, higher, quicker, without, worrying about that and all the regulation, there's actually been a lot of other safety that's been brought in. So, some of the things that we're solving, doing, high speed, head-to-head racing, that, even though we're not thinking about human safety, that's going to directly apply and bring in more safety to, the everyday, autonomous vehicle or even those ADAS systems.
It may be worth mentioning, too, that even though in this context, right, we're not talking about human safety, but on the other hand, these are expensive physical assets that are in limited quantity. So it can't be no safety, total Wild West. And so it's I think Will kind of outlined it really well, that these guys have to think about it because they only get really one chance with this very expensive, unique asset.
It's the risk reward.
Yeah.
I think safety is a really interesting kind of concept. The bottom line is safety adds no value to the product in the consumer in the consumer's mind, but they will not buy a product if it's not safe. So nobody's running around going, I want 10 units of safety as opposed to 9 units of safety and I'll pay more. They're looking at it going, it's either safe or it isn't. And if it's safe, then I buy for other features. And this has been something that we've seen in many industries where it's the commoditization of the process of safety is really important because that matches what happens in the business model. And so I think by ignoring the safety aspect in solving some of the autonomy problems and thinking it's something that we're going to end up solving at the end, you actually create a process where safety becomes much more difficult and more expensive, as opposed to thinking about it as a commodity step that you need to build in foundationally from the start. And I think that's perhaps something in the rush to solve the autonomous driving problem that has been missed. People are now recognizing it, and we're seeing things like we're part of a a consortium called the Autonomous Consortium, which has technology companies, it has automotive companies, it has tier ones, it has a lot of different organizations coming together to say, all right, what is the safety foundation that we all need to be able to build up to, and defining that, because it's of no advantage to any one company to be able to solve that. You want everybody to agree, what are the safety standards, what are they going to look like, what are those technologies going to be, then we can innovate. And once you've taken care of that checklist item, then the innovation, and then you can get from, as Will is doing, getting up to the 100, 200 mile an hour kind of solving those problems, because you're not worried about, is this piece of technology going to function the way that we think it should function? Creating a safe platform for innovation is the route forward.
And there probably is a market opportunity, right? So on the one hand, safety is very difficult, right? We talk about functional safety, all the software development, the hardware, the interfaces, and the training of the models. But if we can modularize or structure these autonomous systems into subsystems that are predefined and pre-developed, because we know that there's a lot of autonomous integrators going to be out there, right? And they're not all automotive, right? So they're not all race cars at 200. It's going to be, autonomous factory vehicles, mining, agriculture. But I think there is a place for a technology ecosystem that has thought about that, even though, it's going to be a diverse ecosystem of these new vehicles. And frankly, somebody might think, hey, it's an agricultural application. I've got 40 acres of field around me. I don't need to think about it as much. Well, the reality is they probably do, right? But if they're buying components that have had that intrinsically designed and able to, simplify that safety system, that safety challenge, then I think the industry is better served, because we're getting more diverse products to market. But, we've also captured value for an ecosystem of companies that are working on the autonomous layer.
That's a really nice segue into the next question. So we fell into the trap a little bit of talking about cars, which I knew we would, because that's what we do. But of course, there are so many other areas of autonomy that require some kind of autonomous operation, different market verticals, different applications. But I guess it's fair to say the car industry is putting a huge amount of investment into making that a reality. So what role do they play in, seeding that technology into these other sectors? Is it fundamentally the same problem we're trying to solve?
Yeah, I think from a technology standpoint, it doesn't necessarily differ that much if it's an autonomous car or, a robot in a factory. You still have the same building blocks, the application's different, but you have, the perception, you have to know where you are, you have to be able to make the decisions and execute it. And so all those skills and all of that, domain knowledge really applies across the board. So having that investment coming in the automotive industry is creating a lot of knowledge base and a lot of talent at those companies. And then, that's just going to spread and really be applied all over, I think.
I think the automotive, the passenger car industry is going to drive a lot of that, a lot of commonality. But I do think there is room for variation, right? So, we have to see, we have to sense, we have to understand the environment, and we're going to be, I just kind of rattled off a list of, mining, ag, manufacturing, and a whole plethora of others. There's a lot of value to be captured in those markets, whether it's due to, labor shortages or, human safety due to the environment. And, but, those use cases may require, some unique sensing technologies to solve that problem. And so I think automotive in a lot of ways is going to drive what I'll call a lot of the core technologies, algorithms, embedded processors, certified hardware, things of that nature. But I think increasingly we need to get to an area of more of a modular toolbox where we do have the ability to bring in new sensors to help understand the environment that these. I don't even think we've really scratched the surface about the level of autonomy, and there's going to be new companies that are popping up with small, medium, and large scale applications. So these tool sets become, I think, absolutely critical.
Yeah.
I wholeheartedly agree. I think it's an ecosystem that needs to mature and develop where you think about autonomous functionality as a block. So it's a vision kind of block, or it's a route planning kind of a block, or whatever. Those then can transcend across different industries, and it becomes purely the scale at which you're doing those particular tasks. If you're doing, for example, vision perception in a car, racing car, 200 miles an hour is probably at the extreme level. Fundamentally, it's the same process that we're doing in a plane at Mach 2. It's the same, but the scale and the complexity is the only thing that changes. When those two pieces of technology are fundamentally the same, and they're mature enough to be building blocks, so that the rest of the ecosystem can survive on them. And the only thing that changes is how much processing power you put to the application. Then I think we'll truly be in that position where we can innovate and move forward. If you think about what the challenge is, if you pick just something simple like vision sensing, we've seen two applications in terms of the IndyCar driving, and then you look at something like the technology from Omar that I showed earlier, that little drone. They're having to do the same thing, but on tremendously different scales with tremendously different processing capabilities, tremendously different energy capabilities. There's an energy constraint in one that isn't in the other. The thing I think is missing are companies who are willing to invest and innovate horizontally. And I think the first wave of automotive kind of investment was so vertical that it stopped people thinking that way. What I'm heartened by now is the automotive guys are like, we can't do this all top to bottom. We're seeing that our structure isn't right, and it's very interesting that we have one customer that we're in discussions with on prototyping, who probably have 4 or 5 different autonomous projects and investments going on simultaneously. And what they've realized is they just have to seed a lot of different approaches, some in-house, some external. They're spending billions of dollars in each of those pots, which is very, very welcome because innovation needs money to fund it. So I think there's a sea change for the better in the automotive world, where they're starting to become incubators of technology as opposed to trying to be linear problem solvers.
So I want to make sure we leave questions at the end, or time for questions at the end from the audience, but one last question to each of you. So as a species, are we ready to give up control to the machine?
Yeah, I mean, it depends what you're asking me to give up. If it's stop and go traffic, 100%. If it's a nice mountain drive, then I don't want to give that up. But I think, it really comes down to people's trust in the technology. It's not that hard to make an autonomous car that's a better driver than the average person, but no one's going to trust it until it's 100 times better, than the average person. So, from my perspective, I have lots of friends and family that think I'm crazy to, write some code in an autonomous car, sit in it, testing it on the street, and see how it goes. But from my perspective, I'm like, this is better than most of the people on the road. So it's just that trust level. But then you also talk to people that just, aren't there and are never going to trust it if it's not something that they can really understand. So as a species, maybe not, but as subsets, I think so.
I think we'll be more amenable to interacting with the technology than maybe we predict. And the anecdotes that give me confidence are, look at our children. The way my kids interact with technology, it's very much seamless. It's part of their life. They're a generation that comes with it. In our work lives, even in say factories today, seeing big robotics in factories is not unusual. It's common. Cobots are coming into the manufacturing environment. Humans collaborating with robots side by side. The Omar drone. You just mentioned that. To me, that looked like a drone-based cobot. Right? We're becoming more familiar.
Yep.
And so I think. And then as soon as those use cases happen that come to fruition that resolve or take away some sort of mundane activity, the daily commute that Will was referencing, then I think that's a piece of work or a part of your quote life that you want to cede because you want your time, that one commodity we can't get more of, and you want to spend that time on some other productive activity. So I think that it'll be incumbent on the industry to find those pockets of value to build the familiarity in kind of multiple segments of life. But I think the change will happen, and it won't be quite as disruptive as maybe we think about it from watching the movies and things.
Interesting.
So I think this is like the frog, isn't it? You throw the frog into a boiling pot of water, it jumps straight out. You put the frog in the cold water and boil the water, and it stays there, and it doesn't see the difference. And I think we as people are going to be like that. We will autonomy is already dripping into our lives, and we just don't notice it. The amount of control we give up, take a ride on the Ferris wheel. You've got no control of what's happening to you. If you're in a plane, you have no control of what's happening to you. You don't know whether it's the autopilot or the pilot that happens to be flying. We're working with an incredible guy called Pascal Traverse at Airbus, whose job it is to remove the pilots from the planes. Now they're not there yet technically, and they're not there yet kind of business case wise, but they can actually make a technology case where you don't need a pilot to fly a plane. So now you've got 300 or 400 people relying on a piece of technology. Those things will happen. We're kind of used to getting in small trains that don't have drivers, and I don't think we ever think twice. If you arrived here at Las Vegas and got on one of those, there's no drivers, so you don't think about it in those controlled environments. It will just happen that we accept it. My wife swore that we would never have a robot in our house. While she was on holiday, I bought her one of the iRobots. We now have 6 iRobots and no Hoovers in the house because it was like, oh, okay, this actually makes life easier and works for us. Why am I bothered about the robot issue? It disappears. It just 10 o'clock every Tuesday and Thursday, our house gets cleaned by robots. That's normal, So, yeah, I think we will absolutely adapt as a species. We already are.
Yeah.
It's too late.
Too late.
And the other question is, are you going to let your son drive your DB, your Aston Martin, the day he gets his driving license?
He doesn't want to drive.
Oh, well, there you go. Problem solved.
I've been trying to put him in a car for a long time, but he's just not interested. He's of that generation where driving is a chore and there's no value in it because he can jump in an Uber or whatever comes next and be getting on with his life and not have to worry about driving.
Isn't that
a generational thing?
Yes.
And no, I wouldn't let him drive it anyway.
Can I drive your Aston Martin?
Absolutely.
Oh, that's very nice.
Okay, so with that, thank you, panel. I'm going to open the floor up to questions. If anybody wants to shout something out to one of our panelists or me, I don't mind.
As long as it's got nothing to do with the Commodore 64, we're okay.
Who are you asking? Who's the question to? Whoever.
Are you talking about in the context of the autonomous race, or?
I would say autonomous driving in general, algorithms.
I mean, for us in particular, you have to start in simulation. So, I mean, you develop the algorithms based on your knowledge and stuff. So you think, okay, this could work, this could be good. Then you validate it with some simple simulations. Then you put it in a more high fidelity simulation. Then you bring in hardware in the loop simulations where you're running the actuators and sensors and computing, because obviously computing power can be a huge constraint, and in a dynamic system, those latencies, that lag can cause something that's theoretically stable to go extremely unstable. So you validate it there, and then when you put it in real life on the track or on the road, you have to start and kind of ramp, or as what we do with the racing is you ramp up the speeds, you increase how aggressive the maneuvers are, and you watch the data. And so we kind of just take that incremental approach to build trust in the system and to make sure that what we're seeing in real life matches the simulations. Because if you can build that fidelity between the two, then you can have people just constantly running simulations, and you can get a lot more tests done than you have time to do in actual testing.
Okay, thank you. Any other questions? No? Okay, well, so I'm not convinced we solved the problem of autonomy tonight, but maybe we got a little bit closer. So still, good news is there's still work to be done for us in the room. So I'd like to thank each one of you for participating. Thank you for your insights.
Thank you.
And we still have a little bit more time for drinking and networking, so please make use of the facilities with the time left. I'll take this opportunity to thank every one of you for coming out and joining us tonight as well. It's been an absolute pleasure having you here. Lots of new faces that we've never seen before, so that's what this is all about as well, growing that network. So thank you all for coming out. It's been a lot of fun, and I suspect we'll be back next year. Thank you, everyone.
Thank you.